Hey, welcome back. We are absolutely surrounded by billions of smart devices, and they are creating a literal tsunami of data. So today, we're going to figure out how we can possibly tame that wave and turn all that chaos into some real clarity.
It's a really good question to kick things off. I mean, think about it. Your smartwatch, your car, the thousands of sensors in a factory, even your smart thermostat at home, they are constantly chattering, constantly generating information. So what happens to it all? Does it just kind of disappear into the cloud?
Well, the answer is it all adds up to a number that is just mind-boggling. We're talking about zettabytes of data. Now, to put that in perspective for you, a single zettabyte is enough storage for something like 30 billion 4K movies. And our IoT devices are churning out many of these every single year. So to handle this flood, we need some seriously smart strategies. Because this isn't just about storage anymore, it's about understanding what it all means.
And right here, this is the real kicker. It's not just the sheer volume of data that's the problem, it's that the data from a weather sensor speaks a totally different language than the data from a factory robot. This creates these isolated islands of information, which makes it almost impossible to see the big picture.
So, our first big challenge is basically a translation problem. How do we get all of these different devices and data sources to speak the same language so they can finally start working together?
And the solution is actually a pretty brilliant metaphor. Think of it like we're building a global digital library. Instead of a bunch of separate books that don't know about each other, every single piece of data is cataloged, linked, and understood in relation to everything else. It creates a true global web of data.
The architectural plan, the blueprint for this library, is a concept called linked data. And get this, it was pioneered by the inventor of the World Wide Web himself, Tim Berners-Lee. It's basically a set of rules for publishing info so that machines can't just read it, but can actually connect it to other data all across the web. Okay, so if linked data is the grand plan, then the Resource Description Framework, or RDF, is the actual language we're going to use to write all the little catalog cards in our library. It's a super simple but incredibly powerful way to describe things and, crucially, the relationships between them.
And what's so cool about this is how simple the language really is. Every single statement is what's called a triple. First, you've got a subject. That's the thing you're talking about. Then a predicate. That's the relationship. And finally, an object. That's the value. So you get a sentence like sensora has temperature 22 degrees Celsius. It's simple, it's clear, and a machine understands it instantly.
Of course, a library this huge needs a place to live. You could go with a centralized system, putting everything on one massive, powerful machine. That's really fast, but you're going to hit a limit eventually. Or you can go distributed, spreading the data across tons of machines. That gives you way more power, but things can slow down because they all have to talk to each other. It's that classic trade-off between speed and scale.
Okay, so we figured out how to make all our data understandable. That's huge. But what about the data that's not just sitting there? What about the data that's constantly flowing in, changing every single millisecond? Well, that brings us to our next big challenge, real-time processing.
And this metaphor just perfectly nails the stakes here. I want you to forget about a quiet library for a second. This is more like a crazy busy air traffic control tower. You have planes, or data points, coming in hot from every direction, and you have to spot the critical patterns as they happen to avoid a disaster or, seize a huge opportunity.
The technology that's actually powering our control tower is called Complex Event Processing, or CEP. It is specifically designed to sift through these massive, real-time streams of data to find those really meaningful patterns and the complex relationships between a bunch of different events.
And it's really important to get the difference between CEP and regular old stream processing. See, stream processing might tell you the average temperature from one sensor over the last minute. That's useful, sure. But CEP could tell you when the temperature, the humidity, and the vibration across multiple sensors all hit a dangerous combination at the same time. It's all about seeing that bigger, more complex picture.
And this isn't just theory. This stuff is being used everywhere right now. We're talking about factories predicting when a machine is about to fail, retail stores figuring out the perfect layout by watching how shoppers move, and in our cars, processing dozens of inputs a second to keep us safe on the road.
All right, let's move on to our final challenge, and this one is a monster. We've got understandable data. We've got real-time processing. But what happens when the dataset itself is just so ridiculously massive that no single computer or even a whole group of them could possibly handle it? This is the world of big data.
You've probably heard it defined by these 5 V's. We've already talked about volume, the size, velocity, the speed, and variety, all the different formats. But you also have to think about veracity, like can we even trust this data? And ultimately, the most important one, value. Can we actually get useful insights out of it?
So how on earth do you tackle a problem that big? Well, we've got another fantastic analogy for you. You wouldn't send one person with one tiny shopping cart to buy 500 items at the grocery store, right? No way. You'd use teamwork.
This teamwork approach is actually a famous algorithm called MapReduce. The map part is where you break up the huge task, that giant grocery list, into smaller, specialized lists. You send one person to produce, another to the bakery, and so on. Then the reduce part is when everyone brings their items back to the checkout and you combine it all into the final result. It's a beautifully simple idea that makes processing these enormous data sets actually possible.
Now, to pull off this kind of teamwork, you need a totally different kind of storage system. Your traditional, rigid, old-school databases just won't cut it. You need what are called NoSQL databases. They're flexible, they're scalable, and they are built from the ground up for the messy, unstructured chaos of big data.
And there are a few different flavors, each one designed for a specific job. You've got key value stores, which are like super fast digital filing cabinets. Document stores are awesome for flexible data, like for web apps. And graph databases are perfect for understanding relationships, like in a social network or a recommendation engine. So let's bring this all home. We've looked at 3 absolutely huge challenges, and we've walked through 3 incredibly powerful solutions. But how do they all fit together to create one single cohesive system? It really is all about teamwork. Our semantic library makes all the data understandable. Our air traffic control system, that's CEP, processes it all in real time. And our shopping team, that's MapReduce, tackles the massive volumes. Put them all together, and you have this incredible pipeline that transforms raw, chaotic data into clear, actionable knowledge. And why does any of this matter? Because this pipeline, this is what is literally building our future. It's what allows a factory to fix a machine before it ever breaks. It's what helps a city manage its traffic flow intelligently. And it's what lets a doctor get real-time alerts from a patient's health monitor. It's making our world smarter, safer, and way more efficient.
But as we get better and better at taming this data tsunami, as we master the technical side of it all, we're left with one final and maybe profound question. We are building these unbelievably powerful tools to create knowledge. The challenge for all of us now is to build the wisdom to use it well. Thanks for exploring all this with me.